Hello everyone, welcome back to another episode of Ali Explains Software Development. In this series, we are focusing on solution architecture and a very essential topic, distributed systems. In the previous episode, we have seen in the airport example how a monolithic approach causes an airport to function poorly. Today, we are going to talk about the solution to this problem in detail. The most important part is to understand how we can overcome the problem. We take the airport model example today and dig deeper into it and go through a feasible solution. There is not much of a difference between what is going on within businesses and the day-to-day processes around us. When you think about it, the people behind software engineering and architecture principles know business models, business processes, and how they work. This is why I always emphasize that learning software engineering requires thinking and learning processes, and these apply to real-life examples, especially on the economic and business side. So, a quick review of the first video about the airport model. When we have a monolithic approach, the long queue at the beginning of the first counter will cause many people to turn around or lose their patience. It is a horrible user experience. However, as soon as the passengers get to the check-in counter, everything will flow smoothly and provide them with a pleasant experience. In the monolithic approach, you have one single service, that super lady over there, serving all of the customers. If you have 50 staff, you can help 50 people at the same time. The customer will be attended to by that operator, serving them until the whole process is over. If anything goes wrong in between or things get out of control, we will run into resource shortage. It means that any problem or failure in the system will surely increase the resources required for handling the whole process. That's basically the most significant issue we have with the monolithic approach. I repeat all this again and again because that is the basis of distributed systems. We know from the previous video that every person will need to be trained for every sector. More issues revolve around how difficult it is to bring one new employees with diverse skills. And finally, there is the risk of corruption. If you have one person handling everything, you're increasing their corruption risk in the whole process. Precisely, the same applies in software engineering and in solution architecture. You need to be aware of fighting corruption in your technical solution. One of the most significant benefits of digital transformation is fighting corruption in the system and subsystem. I'm not talking about business or financial corruption in this case. However, when it comes to technical corruption, not having chaotic data or a massive amount of data without a clear context, it will go under the corruption risk. A system that handles orders needs to have a distinct responsibility, and that's what we are going to discuss together. As I mentioned previously, having one long-running process is impossible. So we need to divide it into 4 independent and separate processes while training the personnel to handle each task independently. Each step is completely different and they do not communicate directly with each other. As a passenger, you go to the check-in counter, get your boarding pass, and then go to immigration. No one will be responsible for bringing you to the immigration counter or any other subsequent steps. You just know the whole process, which is set and defined by the airport. You will find signs everywhere knowing that you need to pass 4 independent steps to go on board. No worries, if you are traveling for the first time or you just happen to forget about the processes, each sector will ensure that you have completed the previous one again without communicating with the other sector. That is the boundary of the system, and that is obviously clear enough. For example, the stamps and the confirmation or proof you get on the passport from the previous step, which grants you to pass the other level. So you successfully transfer from one process to another with all the necessary documents until you get to the final step of boarding onto the plane. We call this the distributed systems approach in a closed and well-orchestrated environment. You decide as a passenger when to start the process and move to the next one. Then you check in, and maybe after that you can choose to spare some time for dinner before you go to the immigration. There is no rule to force you into completing all the processes right away, but if the flight is at, for example, 2:25 p.m., then there is a time limit to finish the whole process. But when do you start and how you use the time in between is absolutely up to you. The first example of the monolithic approach is about how you start the process and finish it. Even if it takes 2 hours or include any issues, you have to complete the whole process. From the business perspective of a distributed system approach, you define the same process in your way. So, in this case, that you have some time to spare between getting bored into the airplane, you could easily use a meal or a cup of coffee. This increases the opportunity for businesses to create advertisements, sell food, and countless different items. An excellent technical solution has a considerable value proposition enabling businesses with extensibility and agility. Basically, check-in personnel have no influence on the passenger's transition to the immigration, which also means that those services utilized in between upon your choices are not part of the transition. This is beneficial for each service, and it also creates a high potential for managing efficiency, control, and even business opportunities. Now imagine you've passed the immigration process and you are walking around the duty-free or any other place that the airport management has designed in the system without jeopardizing the main objective of the whole airport experience. All the businesses in the airport are benefiting from having a distributed system. We now understand another benefit in the transition that can be managed and designed separately. As we have mentioned earlier, the airport management can add or change the services or businesses between immigration and security without jeopardizing the principal objective, which is serving the passenger in the airport to catch a flight. This results in an increase in revenue and a decrease in operational costs by integrating with third parties. This is a massive benefit of the service-oriented and distributed systems approach. The same applies to software architecture. You have customers or users coming into your platform, but you have third-party integrations, right? The customer can also interact with those third parties. You don't have to implement everything by yourself when you can integrate seamlessly. You can change your solution from a pure software solutions into integrated operations solutions and have multiple reliable third parties to participate in enabling your capabilities. At the same time, you take the full ownership of the process and the data. This is only possible if you are following a distributed systems approach. A solutions architect's nightmare is when you go for an enterprise and big process-oriented solution with a monolithic architecture. If you are walking around freely in the airport, security personnel might come to you randomly and ask for your documents. This is called controlling. If you build a system that is easy to control and audit every transaction inside your system, you are creating a very secure practice. These audits needs to be possible to build additional services in your solution or software independently. We see that it is much easier to integrate our process with different third parties or expand the search systems and service portfolio without touching the running system. We can easily measure each step's performance. When you have the statistics separately for your different service points, for instance, check-in counter handling 1,000 customers per hour, immigration handling 500, and security taking 200 customers per hour, you can easily manage the infrastructure and the personnel. When the check-in counter manages a speedy process, you can build various integrations and engagement-related facilities for the customers before they reach the immigration process. That way, you will improve the passengers' journeys and make their waiting time to your benefit. Such transactions could include adding more shops or exciting advertisements. Another quick example I want to provide you is a purchase you're making online. Imagine you are ordering something through Amazon. After your order has been confirmed, you'll receive an email, usually where it says that it will take 2 to 3 days to deliver, and if after 3 days and your parcel isn't there yet, Amazon takes the initiative by sending you an email providing you with compensation. Like a free ebook, for example, something that makes the customer accept the inconvenience. In this case, Amazon is controlling each step of the transaction and measure their performance. If they are not performing well, you are now in transition, and that's when they try to take care of you individually. That is a beautiful approach, and it's not only technical, it also helps the business build better business models and implement higher customer success. Now let's go back to our airport example. Assuming the check-in service closes at 10 p.m., the people in charge get to go home, turn off the lights, and save a lot of infrastructure and electricity and personal costs in the check-in counters. The immigration sector still operates until 11 because you go to immigration after check-in, right? So each process can be shut down or scaled down in terms of resources. The load is plannable. If the airport starts to operate from 6 a.m., logically check-in and immigration counters will run earlier than the security and boarding sectors. So that is how the concept of different kind of load balancing applies in the management of resources in distributed architecture. Unlike the monolithic approach, where you will need everything to be operating simultaneously. Let's talk about a unified process and independent states. You know that there are 4 steps to complete before getting on the airplane. If you decide to manage your time between walking around shopping or having a nice meal, it's absolutely up to you. If you fail to manage your time and miss the flight, then none of those processes make sense anymore. You have to finish the whole process before the airplane leaves and before the gates closes. This is an essential part of the entire process. There is a deadline for the tasks you must finish. In a monolithic design, your role is to remain in the first queue while getting your services processed or done all together at once by the only staff you are dealing with. However, in the service-based architecture, you are responsible for collecting the necessary information, holding it, and passing it to the next service. You cannot lose your documents along the way. Moreover, there is also a higher chance for random checkups, as a security personnel might randomly check on you and your papers. Again, it is all part of keeping the system at maximum security without risking any sort of corruption from happening. It is essential to understand your system's boundaries. Basically, when you define those 4 processes, a passenger must take it in a specific order. Once you complete a set of events in the process, the data can no longer leave the system. When you finish the immigration stage, you cannot get back to the check-in stage anymore. It is impossible to repeat the immigration step. Of course, under normal circumstances, the process is one way and you can't come back. But if you have passed the security gate, you might still want to come back to the shops for food and redo the security check. But if you do this very often, the security personnel might think you're planning something shady. We call it anomaly detection. The same thing applies to software engineering. If, for example, the same exact message is being sent to the same service very often, sometimes it could indicate that there is something wrong. As a solution architect, you set an anomaly detection. Artificial intelligence continues to notice why this message is being handled so often with the same service. It will then troubleshoot the root cause. In the last part of this video, I will discuss on how solution architects handle failure when it comes to software solutions. You have to do health checks at the airport. They do health checks all the time. It's just a guaranteed way and a necessary step to ensure there is no issues or problems. In the case of distributed systems, you can check every single step separately and differently, which is beneficial in software engineering services. Some part of the system must run smoothly without any issues, and you will make sure that you check the health of the system even more often than usual. Other part of the system, if, for example, you make a mistake, it could still be tolerated. In cases where issues occur in the immigration or security check-in, that's when it cannot be accepted. So you need to put different kinds of service level agreements or key performance indicators or security measurements for an intensive check on the health of the system. Bearing in mind that each part can be monitored differently. It is essential that if something goes wrong, you can stop that part of the process, fix it, then start it again. Imagine that immigration has an issue. Whether it is a software or security issue, they will stop the ongoing system for a while and make the passengers queue for a long time while handling the problem. After the immigration is running again, the supervisor might ask 2 or 3 or more personnel to assist in getting rid of the long queue and to ensure that everything will be harmonized again in the system. This is the elasticity we are talking about here. That's precisely what happens in software engineering. If you have different services like order management or shipment, each of those services could be stopped when an issue occurs. Yet you can still fix those issues and start again while your customers can continue to purchase one of your products online. However, you won't be handling their orders yet, which is fine. So this separation means you can fix problems in your system and address issues without shutting down your primary business or process, which is extremely important nowadays for businesses. Otherwise, it would be such a disruptive inconvenience if you had to shut down your whole process every time you face a problem in one of the services. Issues or bugs are also not the only root cause of stopping some part of the system. Maintenance or system upgrade happens often. If you want to upgrade the immigration regulations, you can send 50% of your employees to the training, while the other 50% are working with the old practices. After the first batch of people are back from the training, you send the next one to the training. Everyone set a deadline and apply the new rules. You have done a smooth system upgrade without interrupting your business. In the upcoming episode, I will discuss how you can make sure that each process runs independently from each other and the differences between microservice architecture and distributed architecture. In these episodes, we are focusing first on a very high-level understanding of the business proposition before we go deeper into the code and technology part. Thank you very much for being here, and I hope you have enjoyed and learned from this episode. Subscribe to our newsletter. See you soon.